Hello and welcome to test 11, where I'll be doing a full walkthrough of my solution to creating a path-finding algorithm with a terrain generation. When we load into the program, we are presented with a 2D window. We can see the name displayed at the top here, Eiger 3D. This is named after a famous mountain in Switzerland called the Eiger, and kind of resembles what my program aims to achieve with mountainous terrain. You can see down the side here we have a list of functions. When you're first loading in, as a user, it may feel quite overwhelming, but I think clear labeling and vibrant buttons with contrast between the background and the buttons helps to bridge the gap between the understanding. First, we want to plot a route by clicking on the start and end node. I'm going to make it similar to how a route would be plotted in real life, where you'd have the start and end point in the same location or adjacent to each other. This could simulate, for example, starting a walk at a car park or a bus station, wherever it may be. Typically walks are in a circular fashion, so I'm going to use intermediate nodes to determine where I want the route to go through, and coming back round to the end node. If I generate the route here, we can see the route goes around in a circle, starting at the start node and ending at the end node. I just moved it about so you could see the clear distinction. We can also see a side elevation profile for the undulation that the route goes through. We can see this variation throughout the terrain, and you can see on the map the different colours going from darkest, which is the areas of lowest elevation, to lightest, which is the areas of high elevation. You can see the route cuts through many of these different patches of colour, indicating that it goes over different portions of mountains and valleys. Route statistics along the side here, we have the length, which is 10.5 kilometers. I'd say that's very accurate to a real life walk. A day's kind of walk could be around 10-11 kilometers. Maximum elevation 1,333 meters. That's very similar to what you'd find in the UK in a mountainous environment. For example, in the Lake District, the mountains go up to about 1,000 meters, or if you're in the Highlands up by Ben Nevis, it goes up to about an elevation of 1,300 meters. So this is very similar to an environment that this software may be used in, which is in the UK. Minimum elevation of around 99 meters. That's very common as well. I mean, you get valleys that go almost down to sea level wherever you are in the UK. Total elevation and duration here. Duration 2.6 or so hours. I think for a walk of this size, that's quite a fast walking pace. However, if we go into preferences here, we can decrease the walking speed to around 2 or 3 kilometers an hour, and you can see the duration increases as you're walking at a slower rate. So the duration or the time the route's going to take to walk will increase. So the user has options to choose this. We can increase this up to a maximum of 10 kilometers an hour. However, that would be a very quick and unrealistic walking pace, but it's there if a user wants to use it, or for example, if they were plotting a route to be done as a walk/run or jog, you may be going up to around 10 kilometers an hour. Similarly, if we go down to 1 kilometer an hour, this could be used to kind of a worst case scenario if you were deciding how much time could the walk take in the worst conditions. If you've got a thunderstorm, or your navigation is hard, or you were out for a walk with small children or elderly people who can't walk very fast, you may be selecting 1 kilometer an hour or 2 kilometers an hour, something very slow, just so you can approximate the time in a worst case scenario. We can also switch between imperial and metric measurements. This is to facilitate a wide range of users. Many people may be comfortable with metric units, others may be more comfortable and can visualize distances better in imperial measurements, so they're both there, and you can see this updates accordingly. Next, the coloring tab. We can change the different colours of the lines, the line width, the node colour. Width is primarily for different users so they can see kind of the different thickness. It might not be too distinctive for some users with poorer eyesight at 2 parts. So we can increase this all the way to a maximum of 8 parts. We can also change the line colour. This can facilitate any user that may have a visual impairment to certain colours, or just for personal preference, you may prefer one colour over the other. Similarly, we can do this with all 3 of the node colours using the drop down menu here. We can make every node the same colour, changing the start and end nodes to also be yellow, or we can change them back to different colours. Similarly, we can change all the intermediate nodes at once and hide this form. We can clear this path away. You can see this resets and gives null pointers to all of the root statistics and also erases the elevation profile. And then we can start again, plotting a new route. We'll go up this way for now, or this time we'll do a route where you're going from A to B. Generating that. We can also have it where we have a random scattering of intermediate nodes on the grid, and say the user wants to get between different locations on a map, multiple locations, but they want to start and end in a specific location. An algorithm should find the most efficient route to travel between all of the nodes and end at the end node, as seen here. And we can move this around, add more nodes. Once again, we can observe a most efficient route between all the nodes. You can see this elevation profile here. Increasing the width scaling now, first that resets everything because the map size has increased. Go all the way up to a maximum. This would be used for large scale terrains, you know, a whole landscape of quite barren terrain where there's not really much going on. Or we could go down to very small zoomed in map scale where you might not have much going on. Over a long distance, but over a short period you might have a lot of detail you want to zoom in on. Generating a route. And then we can export this into 3 dimensions. You can see this clearly here. The user is allowed to orbit the mesh around. They can also use this toggle feature. That will orbit the terrain automatically. It gives a nice rendering of the terrain, increasing the octave, decreasing the octave number, just to try and get a nice generation of terrain. We can also regenerate terrain using the regenerate button. If I hide this and create a different route. Actually, first I'm going to increase this scale, then I'm going to create a new route. You can see if we go through the portion of low elevation here, and then we can wrap around between kind of 2 portions of higher elevation. This would be more of a valley walk. Generate that. Move that here so it's in line. And we can export this into 3 dimensions. See that we're going through mainly the areas of lower elevation. It's nice to also observe that the compass updates. This is a feature that would take place in real life. where you can see the orientation of the map. So if you can line it up with a physical map you had and tell which way is north. It's just easier to map read when you have some kind of pointer to the direction of which you're heading. We also have this information on the side. You can change the extremity value of the terrain, change that to 40, change that to 50, excuse me. So now you can see the terrain has lowered, and we've got more of an extreme difference. If I go up to a maximum of 60 or 59, see that extremity has kind of pulled out a little bit more, and you can see you've got these larger kind of mountains and lower valleys. Put this back to a 30, and we can see the terrain has now much more flattened out. And if we go up to 20, we get a much more flatter terrain, but whilst keeping it all in proportion. So this is still areas of darker, and this is areas of lighter, so lower elevation, higher elevation. But you can see that the distance between the lowest elevation and the highest elevation is much less. I think that's everything. We can clear this away, and the user's free to plot as many routes as they want on the terrain. And yeah, thank you very much.